Hi everyone, this video we will talk about some sorting algorithm. For this class, we will introduce couple sorting algorithm. All of them, they will use the nested for loop to perform the sorting. So the big O runtime will be n squared. So start with the nested for loop I introduced you last week. Remember last week I quickly to show you the sorting algorithm we using to sort our movie. So this one we call the nested for loop sorting. You can see here we have a two for loop. The outer for loop will go over the element one by one, start from 0. The inner for loop will start from the next element from the outer for loop, then we will finish to the end. We see the example like here we have 10 elements in the array. They are not in the sorted order. So this nested for loop they will do is, we see the outer for loop. I start from 0, so that's why we start from this index. So then in each one we start from I equal to 0. So then I start from I plus 1. That means start from 56. So then we will go over 4, 10, 77 until 52. So the algorithm for this nested for loop is, we're using this 34 for target. We're using this one to compare each element. Since we want to then to be in the ascending order, so the smaller number should be at the beginning. So if the index in I is smaller than 56, we are in the right place. However, we see the next one. If 34 is smaller than 4, greater than 4, that means your 34, this value is greater than the 4. We should swap them. So then you will see here, your 4 will come here. 56, still 56, but 34 is here. So that's our algorithm for this nested for loop. So on the other hand, we continue. Since we finished 4, right? So then we swap, now it's 4 at the beginning. So 4 is smaller than 10, wonderful, continue. 4 is less than 77. So less than 51, less than 93, less than 30, less than 5, less than 58. So that's why after the first iteration, our array will look like this. Because the rest of that, they didn't change the value. So that's why you can see in this nested for loop algorithm, each iteration we will have the smallest value in the correct location. So that's why I continue for the second iteration. You see, after we finish I equal to 0, right, we come back to I increment by 1. So 4 already in the correct order. So that's why we will target for 56. So the 56 will compare with 34. So then compare to 10, compare to 77 until 52. So whenever this value is greater than the following value, they will do the swap. So you can see here, after each iteration, they will have one location with the correct value. For example, like the next one, actually 5 will be in the correct location. But here I didn't perform the whole thing. So you will see, because the nested for loop, we start from the inner for loop. We start from I start from 0, then less than 10. So that you will see here, you need to have the whole for loop will be in the sorted order. We need to do 10th iteration for that. So this one, whenever you see if you have two for loop, your runtime big O, if we use the big O notation, okay, so your runtime algorithm will be O n squared. Okay. Yeah, so this one is the nested for loop we use. But the coming click I will talk about is in this week we will talk about insertion sort and selection sort. So that's why here let's see the insertion sort for the next one. So we see what is the insertion sort. Insertion sort is mean I just insert one element at a time. That means, for example, I have the integer array size is 10. So that's my original array. When we talk about insertion sort, that's mean, okay, I add element one by one. So for when I have I have value 34 only. Of course, they are in the right order. So that's why insertion sort actually we start from 2 elements. So after I have the one, right? So then I add the second one. So then after I add the second one, right, I will continue to compare to the previous element. If the previous element is smaller than me, I finish. So on the other hand, you see here, this one will be the first iteration. So then the next iteration, after I have 34, 56 in the order, I add the next element. Okay, so this the next element. So let me add. Okay, this element after I add, right, you can see here, whenever we add a new element, I will compare to the previous one. So if the previous one is greater than me, I will swap. So then continue after I swap 4 and 56, right? Okay, so then the same thing, 4 will continue to go to check from the beginning. So then 4 is smaller than 34. So that's why here my 4 will be here. So then my 34 will be here. So that's the second iteration. So continue, actually you can see each time I just add one more element into my iteration. So after each iteration, so this one 4 and 34, 56, they are in the right order. So that's why the same thing, if I want to, the next iteration we will add the 10. Okay, so the same thing, 10 will continue to compare until you see if this one is greater than me, if this one is greater than, if this one is greater than me, I just need to move. If this one is greater than me, I just swap to move. So that's why here you see 10 and 56, they will swap because you are greater than me. They will swap. Okay, so 10 and 34, 34 is greater than me, so I swap. So then here is the next iteration. So of course we will continue one by one, but the next one I want you to think is, how should we implement the insertion sort? So how should we implement the insertion sort? Okay, we start thinking about what is the outer loop. So just like the example we show you the nested for loop, the outer loop we will see is after each iteration, how they will be done. So the insertion sort you see here, at the beginning we start from 2 elements, because you see every time we add 1, so then if they are smaller, we move to the front. If only have 1 element, kind of meaningless. So that's why you can see they always start from 2 elements. So then you see they have 3 elements and 4 elements. So this one actually is our outer for loop. Our outer for loop will still start from I equal to 1 instead of start from I equal to 0, because we need to have at least 2 elements. So then, right, at the end, the last iteration, we will have all the array elements. So that's our outer for loop. So then what will be our inner for loop? So the inner for loop actually is earlier how we compare one by one. Remember, you see, you start from this one. I equal to 1. So I see if I can move to the front. So that's why here we will have this one, we just say, we call that the small value. So this small value, we start holding from AI. Because one thing is, this one, 56, just right away smaller than 34, so nothing we need to change. But then, did you remember this iteration, the next iteration, we have 34, 56, and 4. So 4, we will compare to 56. If 56 is greater than 4, you see we move 56 to the location for 4. So then continue, 4 actually will continue to compare to 34. So that's why here we have the 4, we need to keep the value. We remember if that is smaller number. So then we need to have another index. This index is for the move index. The move index that starts from I as well. Okay, because here we will start moving from, for example, 4. We need to start moving from this one to the front to the front. Okay, so we start from I. We only move that when the 56 on the previous index value is greater than 4, so I can keep moving. Otherwise, you see like 56 less than greater than 34, I don't need to move. So that's why here we will have a while loop. Because here we see, for example, after we have 4, 10, 34, 56 in correct location, right? Your next one will be 77. If 77 greater than 56, actually we done this iteration, we don't do anything. So that's why this inner for loop, you only while you have couple condition. The first one is if our move index, I will keep moving. If move index greater than or equal to 0, I will continue. And also one thing is, after I try to compare one by one, only my previous index value greater than me, I will move the value to the next location. So that's why here you will see if we say our array name is A, so only your index, your move index, the previous one, okay, the previous element is greater than my small value. Why I need to save this small value? Because later you see they will have like your 4 and the 56, right? 56 will move to the 4 location. So this location will be overwrite. So that's why we need to save this small value to keep compare. So if your previous one is greater than small value, that's a 56, I will move 56 to the 4. So that's why only in these two conditions, I will do two things. These two things is, the first thing, I will have this A move index value minus 1. You see that's the previous one. If the previous one value is greater than me, they will assign to the next location. You see here like 56 need to assign to the 4. So if the previous one greater than the small value, they will be copy over to the 56. That's the move index. And also afterwards, see, I need to continue go to 4 will compare to 34, right? So that's why my move index can decrement by 1. Okay, so that's the while loop. So after your while loop, don't forget, you see, if you have to move, right? So then 4 actually will move to the move index. So that's why here you see your 4 will continue to go here, continue to go here. So then since your move index also keep changing, so that's why here our move index, okay, if I never change, actually they just reassign. Okay, but if they really change, so then here we will assign the small value. Yeah, so this our insertion sort. Okay, so this insertion sort, what we'll do is, so this insertion sort we show you, you see you have one outer for loop. But inside, if the worst case, your while loop will do kind of go over each element. So this insertion sort, the same thing, their runtime will be big O n squared. So this one, my example only show you that's only work for the int array. So the same thing, I want you to run example 3. So this one will give you the main function. And also in the insertion sort, we have the same algorithm, but this one become a template function. So that's why your array can be int array, double array, or string array.